Picture a vast expanse of absolute darkness, stretching endlessly in every direction. Somewhere out there, floating quietly in the freezing void, 40 light-years away from everything we have ever known, we are practically invisible to the rest of the universe. Consider the famous photograph taken by the Voyager spacecraft as it hurled past the outer edges of our solar system. In that single iconic frame, our entire world is reduced to nothing more than a solitary speck. At the time the shutter snapped, the probe was billions of miles away in deep space, soaring far beyond the orbit of Neptune. Looking at that image, our home is barely discernible against the immense black canvas. Naturally, the cameras equipped on an older spacecraft cannot be genuinely compared to the cutting-edge astronomical observatories we utilize today, but the core message remains undeniably powerful. The photograph serves as a haunting reminder of exactly how incredibly small we are, drifting aimlessly through an ocean of nothingness. We are an unfathomably tiny dot floating in the cosmic abyss. Yet, a fascinating paradox exists right here. Even if a highly advanced alien civilization possessed state-of-the-art telescopes aimed directly at our region of space, we would still be practically invisible to them at a distance of up to 40 light-years. This begs a monumental question that challenges our understanding of our place in the galaxy. Why is that the case? Why is it simply not enough that we are here, actively existing, emitting artificial light into the night sky, sending powerful radio signals out into the dark, and yet entirely unseen by anyone else? The profound answer lies buried deep within the fundamental physics of light itself. Every single transmission that leaves our planet spreads outward in a spherical pattern through the vacuum of space. Visualize standing at the edge of a calm lake and throwing a heavy stone straight into the water. The ripples immediately travel outward in all directions, but as they expand over a larger surface area, they become increasingly flatter, weaker, and harder to see. That is precisely how light and electromagnetic waves behave across the vast distances of the universe. With every single light-year traversed, the energy of our signal dilutes over an astronomically larger physical area. The transmission becomes fainter, quieter, and vastly less coherent until it is inevitably swallowed whole by the overwhelming natural noise of the cosmos. To understand this, you must realize that the universe is an incredibly noisy place. It is a chaotic theater of raging energy and violent phenomena. Gigantic stars are burning brilliantly everywhere you look. Massive supernovas are detonating with unimaginable force, wiping out entire solar systems in an instant. Highly magnetized pulsars are rotating at blinding speeds, blasting intense beams of radiation across the galaxy. The vast emptiness of space is actually packed full of roaring electromagnetic interference. Our relatively small signal, originating from a quiet, medium-sized rock orbiting an entirely unremarkable star, has absolutely zero chance of overpowering this raging cosmic background noise. Beyond the vast distances and the deafening cosmic interference, there is another incredibly crucial factor that is almost always severely underestimated by people dreaming of alien contact. We are completely outshone, overpowered, and blinded by the raw power of our own sun. To any potential extraterrestrial observer looking in our direction from a great distance. Our planet is not an independent, glowing object of interest. We are not a bright, sparkling jewel that stands out brilliantly against the dark canvas of space. Instead, we are just a tiny, insignificant dark smudge located dangerously close to a massive, blindingly bright stellar furnace. This star, our glowing sun, effortlessly drowns out absolutely anything and everything we could ever possibly broadcast into the void. Imagine attempting to visually locate a tiny, flickering candle. Now, picture someone holding that barely lit candle right next to an industrial-grade stadium spotlight, and then asking a friend to spot the tiny flame from hundreds of yards away. It is completely and utterly impossible. The overpowering beam of the spotlight entirely devours the weak glow of the candle. Now, take that exact same scenario and amplify it. Imagine that the stadium spotlight is literally a billion times brighter, and the tiny flickering candle represents our entire planet. That analogy perfectly describes the staggering ratio between our sun and our world from an interstellar vantage point. The sun constantly radiates energy with a ferocious intensity that violently eclipses all human light emissions combined. Every single illuminated megacity, every towering transmission array, every glowing satellite, and absolutely all the advanced technology we have ever constructed or will ever invent is dwarfed by our star. We are not discussing a minor discrepancy in brightness here. We are dealing with sheer magnitudes of power that are genuinely impossible for the human mind to fully comprehend or adequately put into normal words. While it is true that our planet does reflect a certain amount of sunlight and independently emits a tiny signature of thermal heat and radiation, all of that data is instantly obliterated by the sun's overwhelming glare. That is the truly terrifying reality of our cosmic situation. We are unknowingly hiding directly inside the impenetrable shadow of our own star. Therefore, even if a highly intelligent alien society actually thrived exactly 40 light years away from us, and even if they possess technological capabilities far beyond our wildest dreams, their chances of finding us remain essentially zero. If they specifically decided to search our exact sector of the Milky Way, they would still fail. They would gaze through their massive telescopes and see our sun acting like just another ordinary, yellowish-white star burning quietly among billions of similar stars. Right beside that star, completely swallowed by the blinding glare, would be us. Over 8 billion living human beings, thousands of years of recorded history. All of our triumphs, all of our loud radio signals, and all of our artificial light would be brutally compressed into a single, meaningless point that instantly vanishes into the static noise of the universe. In a deeply ironic twist of cosmic fate, the massive gas giants Jupiter and Saturn would actually be significantly easier for an alien astronomer to detect. They orbit much farther away from the blinding inferno of our sun, and they naturally reflect vastly more light simply because of their colossal physical size. To truly grasp the immense difficulty of this challenge, Consider our own astronomical achievements. Even the most sophisticated and expensive instruments humanity has ever engineered, such as the glorious James Webb Space Telescope or the legendary Hubble Space Telescope, struggle immensely with this exact problem. These unbelievable machines have extreme difficulty directly capturing images of exoplanets that orbit too closely to their host stars. Bear in mind, these are specialized telescopes that we designed perfectly with all of our collected scientific knowledge, and we aim them precisely at specific coordinates where we already suspect planets might exist. For a distant alien civilization that does not even possess a basic star map of our neighborhood, let alone know exactly where to point their lenses, the challenge is magnified exponentially. Ultimately, the cold, uncaring universe simply does not grant us a fair opportunity to be discovered by our cosmic neighbors. It is not necessarily because we are being too quiet, but rather because we are physically standing in an inescapable shadow. This shadow possesses a staggering diameter of billions of miles and radiates at 5,000 degrees Celsius on its volatile surface. You might be wondering why the specific distance of 40 light-years keeps being mentioned. Why is it not a clean 100 light-years? Why not a massive 1,000 light-years? The distance of 40 light-years is not some arbitrary boundary randomly selected to make a story sound compelling. It is not a beautifully round number chosen purely for aesthetic storytelling purposes. Instead, it represents a harsh physical reality, and it is directly tethered to our actual age as a modern, technology-wielding civilization. Imagine trying to make a phone call to a friend, but the person you are trying to reach is located so incredibly far away that your voice takes several decades just to reach